Hello guys, welcome to my walkthrough of the November 2018 AQA Higher GCSE Maths Paper 3. As always, this is part of my playlist containing all higher past paper walkthroughs, which you can get to down below in the description. Also down there will be lots of other useful bits and bobs, so make sure you take a look. Also, if you're awesome, don't forget, give us a thumbs up, get subscribed. Okay, let's do this. Okay, question 1. A shape is translated by the vector 0, 4. In which direction does it move? So, vectors have two parts. The top number is the x vector. If that's positive, we move right. Negative, left. 0, we don't move left or right. Bottom number is the y vector. If that's positive, we move up. Negative, down. 0, nowhere. So 0, 4 moves us 4 places up. Question 2. What is 1.75 kilometers as a fraction of 700 meters? Okay, so when you want a number as a fraction of the second number, it's the first number over the second. Now the problem we have here is different units. So 1.75 kilometers, multiply that by 1,000 to get meters. So we get 1,750 over 700. Smash that in your calculator. It will simplify it to 5 halves. Question 3. The first 4 terms of a linear sequence are 3, 11, 19, 27. We want to circle the expression for the nth term. Okay, so my sequences playlist is down below. I've got you covered on linear, geometric, Fibonacci and quadratic. So for these guys, find what we are going up or down in. So here we're adding 8. That means it's something to do with 8. N. Now n is the term number, so if we plug in n is 1, we then compare it to the first term. So 8 times 1 is 8. To get down to 3, we need to subtract 5. So it's 8n minus 5. You can check with the second term. 8 times 2 is 16, minus 5 is 11. So there's our guy. Okay, number 4. Work out the lowest common multiple of 20, 30 and 40. So, lowest common multiple means the first number that they all go into. Now we know that whatever 40 goes into, 20 goes into, because 20 goes into 40. So, if we just write down the first few multiples of 30 and 40, then we get 30, 60, 90, on 20. 40s, we get 40, 80, on 20. There's our guy, 120, pops up in both times. Number 5, the length of a table is 110 centimetres to the nearest centimetre. complete the error interval. So I've got videos on this down below. Whenever you round, you make an error. An error interval is the range of values that the actual number could have been before the rounding. So the lower bound is the smallest number here that would round up to 110 to the nearest whole number. So that's 109.5. Now the upper bound, we use the smallest number that wouldn't round down. So that's 110.5. Boom. Okay, question 6. A music festival has taken place each year from 2011. The table shows information about the number of people who attended each year. The festival organisers draw a time series graph using this data. So here's our time series graph. So they plotted the first 4 points. So we got a year along the bottom, a number of people up the side. So just make sure we're happy with the scale. Every one little square represents 100 people. So part A wants us to complete the graph. Okay, so first here we need to do is 2015. So 2015 there were 2,023 people. So we can't do this accurately because of the scale, just above 2,000. So about that. Now in the real thing, doing this up with a straight line with a ruler. Okay, next. 2016 we had 2,612. So that's going to be just above. And there, again, make sure you use a ruler. 2017 was 3,251. So that's gonna be there. And then the final one, 2018, 3,780. So that's gonna be about there. So that is our completed time series graph. Very exciting. Okay, then part B wants us to use the graph to estimate the number of people that will attend in 2019. Okay, so it's pretty much looking like a straight line. So if we just carry it on, it's going to be about there, which is about 4,200. Cool. Okay, question 7. K is n squared add 9n add 1. Mo says K will be a prime number for all integer values of n from 1 to 9. So integer means whole number. We want to show that Mo is wrong, we must show that our value of k is not prime. So the way that we're going to do this then is substitute in values of n and test whether k is prime. So when n is 1, k is, you can use your calculator, 1 squared, which is 1, add 9 times 1, 9, so up to there is 10, add 1 gives us 11. Now 11 is prime. Now if you're not sure on your prime numbers, your calculator can help you here. So if you put 11 in, press equals, you can get 11. Now your calculator can write numbers as products of prime factors. So somewhere on the left you've got, and towards the top, you've got a button with dots and dashes on it. Above it in yellow it says fact. So when you've got 11 up and you've pressed equals, if you then press shift and that button, for a number that's not prime, your calculator will write it as a product of prime factors. If you do it with 11, it will just stay as 11, because 11 is prime. Try it with 8, see what happens. You should get 2 cubed. So that tells us that 8 is not prime, because it can be written as 2 times 2 times 2. Cool. Okay. When n is 2, k is 4, add 18, add 1, which is 23, which is prime. When n is 3, k is 9, add 27, add 1, which is 37, which is prime. When n is 4, k is 16, add 36, add 1, which is 53, which is prime. Again, if you're not sure on the primeness, use your calculator. When n is 5, k is 25, add 45, add 1, which is 71, which, you guessed it, is prime. When n is 6, k is 36, add 54, add 1, so 36 add 54 is 90, add 1, now that gives us 91. Now if you put 91 through your calculator using that trick, you get 91 is 7 times 13, which means 91 is not prime. So Mo is wrong. Cool. Okay, question 8. Doug owes an amount of £600. He says, he wants to pay off the amount in 5 months. He says, each month I will pay back 20% of what I still owe. Show working to check if his method is correct. Okay, so it's important to realise here, he's not saying he's going to pay back 20% of £600 each month. That would work, but he's not doing that. He's paying back 20% of the amount he still owes. So, for example, in the first month, he pays 20% of 600. Now, on your calculator, I would do that as 0.2 times 600, and that gives us 120. So, then, he now owes 600 minus 120, so £480. So in the second month, he's going to pay back 20% of £480. Now, we don't want to do this 5 times. Think of it like compound interest. What we're actually doing is decreasing 600 by 20% each month. So, if we are decreasing by 20%, what we are doing is 100% minus 20% is 80%. So, think about it in terms of compound interest. That's sort of what we're doing, except instead of increasing, we are decreasing. So, we would do 600 times 0.8. 0.8 is the equivalent decimal of 80%. If we only do that to the power of 1, we just get 480 quid. If we stick a power of 5 on it though, only on the multiplier, then that leaves us with 196.61. So he still owes £196.61p. So again, what he should have done is paid back 20% of £600 each month. So £120 every month. Bad dog. Okay, question 9. Now I know everybody loves this question. It's what I've done with all of my minions. So let's go through it. 5 marks. So, a motor racing circuit consists of 2 parallel straight sections, each of length 0.75 kilometers. So that's this guy on the top and on the bottom. A semicircle of diameter 0.9 kilometers. So that's the right hand side. And 3 equal semicircles. Sorry, 3 equal smaller semicircles. Okay, so there's our lap in its entirety. So we know the 3 smaller semicircles are over here. So there's 1, there's 2, and there's 3. Okay, we are told the length of a motor race must be greater than 305 kilometers. What is the lowest number of full laps needed at this circuit? We must show our working. 5 marks. Okay. So, the total length of a race has to be greater than 305 kilometers. that means then that we need to work out the perimeter of this shape. When we know the perimeter, we know the length of one lap. We can then work out the number of laps needed by doing 305 divided by the lap distance. So, for the straight sections, that's quite straightforward. That's 2 times 0.75 kilometers, which is 1.5 kilometers. Okay, now for the semicircles, let's do this guy over here first. We know that for a whole circle, circumference is pi times diameter. So for a semicircle, we're going to want pi times diameter over 2. So this length is pi times 0.9 over 2. So 0.9 pi over 2, well that's 0.45 pi. So that's the big semicircle arc. Now for the 3 smaller ones, we know that they are equal, and we know that in total their diameters have to add up to 0.9. So that means the diameter of each one is 0.3 kilometers. Now, using what we've just done over on the right, these lengths then are 0.3 pi over 2 kilometers. So that's 0.15 pi kilometers. Now we got 3 of those, so 3 times 0.15 pi is 0.45 pi kilometers. So we now know that the one lap is 1.5 add 0.5 from there, 0.45 pi add 0.45 pi, so add 0.9 pi kilometers. Now, at this point, let's put that into our calculators. So, don't forget the pi, classic mistake. So 1.5 add 0.9 pi gives us 4.33 kilometers. Now, if we do 305 then, divided by that, we get 2 seconds. We get 70.4. So that means 70.4 laps would be 305 kilometers. We need, first of all, we need it to be greater than 305, and we want full laps. So it's 71 laps. Boom. Okay, question 10 for 2 marks. Wants us to solve 8 is greater than 3 minus 1/2 x. So, my inequality stuff will be down below. Solving inequalities is exactly the same as solving equations. So, we're not going to want a negative x term. So let's add half x. So we get half x add 8 is greater than 3. Take away the 8, half x is greater than minus 5, and then to get rid of the half, multiplied through by 2, x is greater than minus 10. Boom. Question 11 for 2 marks. Wants us to use trigonometry to work out the size of angle x. So, this is nice, straightforward soccer tour. My playlist is down below. So, in terms of the angle, we've got the adjacent and the hypotenuse. So, is it SOH? S-O-H? No. Ca? C-A-H? Bingo. So, ca tells us cos of x is equal to the adjacent. So, 9 over the hypotenuse, 10. So, to get x out of the cos function, we inverse cos both sides. So, x is the inverse cos of 9 over 10, and that is going to give us 25.8 degrees. So I would always go to 1 decimal place just to be safe. Question 12. Lewis wants to draw the graph of y is equal to x cubed for values of x between minus 2 and 2. Here is his graph. Oh dear. So we want to make one criticism. So the criticism is that he's joined the points up with straight lines. We shouldn't do that. We should use curves. Cool. 13. The probability of heads when a biased coin is thrown is 0.6. The coin is thrown 500 times. Work out or circle the expected number of tails. So, to work out an expected number, we do the probability times the number of times the event is done. So, here we want the probability of tails. Well, if the probability of heads is 0.6, this then is 0.4. So then we do 0.4 times 500, and that gives us 200. Cool. Okay, 14. Right, here then we have reverse mean. So I've got a couple of videos on this down below. So, for 3 marks, the mean mass of a squad of 19 hockey players is 82 kilograms. A player of mass 93 kilograms joins the squad. Work out the mean mass of the squad now. Okay, so think about how we work out mean. Mean is the total, so here is the total mass of the squad, divided by the total number of things, so here the number of players. So what we can actually do before this new player joins, we can work out the total mass of the squad originally, add on the mass of the new player, and then find the new mean. So we know, to start off with, the mean is 82. So we know that 82 kilograms is equal to the total mass, let's just call it TM, over the number of players in the squad, so 19. Now that means then the total mass is 19 times 82 kilograms, and that gives us 2 seconds. That gives us 1,588. So then this new player joins and they have a mass of 93 kilograms. So we then do 1588, add the mass of the new person. That's going to give us 1651. So the new mean is this new total, so 1651 divided by, remember now there's another member of the squad, so there's now 20 of them, and that is going to give us 82.55 kilograms. Cool. Okay, question 15. Now I told my minions when we were going through this question together I couldn't wait to have to explain this in a video, and now here we are. Good times. Alright, 5 marks, and you know, it's going to be good fun when a question takes up 2 pages. So, a company makes 2 types of lampshade using fabric on wire frames. Lampshade A is a cylinder. Fabric is used to make the curved surface of the cylinder, so that just means the bit around the middle. So we got a hole in the top and a hole in the bottom. The cylinder has a radius 8 centimeters and height 22 centimeters. Lampshade B, fabric is used to make the 4 triangular faces of a pyramid. Each triangular face has base 15 centimeters and height 24. So again, the square on the bottom is a hole, there's no fabric there, just the 4 triangles. Okay, we're given a table of costs. So the fabric, for some reason, costs £400 per square metre. Now, I don't know much about fabric, but that seems really expensive. It must be liquid gold or silk, maybe. Other costs for A is £3.50 per lampshade, and other costs for B is £7.50 per lampshade. We want to work out the ratio of the cost of lampshade A to the cost of lampshade B, and that isn't even enough. We want to give our answer in the form n to 1. Good times. Right. Okay. First thing to notice is the cost of fabric is £400 per square metre. So that means we're going to want to convert our measurements, our lengths, into metres, because they are currently in centimetres. So let's do lampshade A first of all. So 22 centimetres is 0.22 metres, and 8 centimetres is 0.08 metres. Now, what's going to happen is this curved surface, imagine we cut it straight down, it unfurls into a rectangle. So, if I attempt to draw a rectangle, it won't go very well, so let's do that. Now, we know this rectangle has a height of 22 or 0.22 metres. What we're aiming to do here is to work out the area of fabric used. Now the base of the rectangle, well, that is the circumference of the circle. When we cut straight down, the cylinder unfurls into this rectangle. So the circumference is pi times diameter. So if the radius is 8 centimetres, the diameter is 16. So in terms of metres, that's 0.16 pi metres. So the area of this square is 0.22 metres times 0.16 pi metres, and that is going to give us 0.11 metres squared. If we go to 2 decimal places. So now that we know the area of fabric for A, we can work out the cost of fabric for A. So the cost of fabric for A, well, we know the area is 0.11 metres squared. It costs £400 per metre squared. So imagine we had 2 metres squared, we would do 400 times 2. If we had 10 metres squared, we'd do 400 times 10. If we have 0.11 metres squared, we do 0.11 times 400. And that is £400. I think that gives us 44. Let me just check. Yep, £44. So then we know that the other costs for lampshade A is £3.50. So the total cost of A is 44 and £3.50, £47.50p. Cool. Okay, so now we need to do the same thing with lampshade B. So the base is 0.15 meters, the height is 0.24 meters, and the area of a triangle is base times height divided by 2. So the area is 0.24 meters times 0.15 over 2, and that is going to give us 0.018. So 0.018 meters squared. So that's the area of one triangular face. So there are 4 triangular faces, so 4 times 0.018 meters squared is equal to 0.072 meters squared. So that's the total area of fabric used on lampshade B. So the cost of fabric for B is 0.072 times £400. Now that is going to give us 28.80p. So we also know the other costs for lampshade B are £7.50. So the total cost of B is £28.80 at £7.50, and that is going to give us £36.30. Okay, so now we know we can write the ratio cost of A to the cost of B as 47.50 to 36.30. Now you would think up to there that's by far enough work for 5 marks, but no. We now want to write that in the form n to 1. So what that means is we need to make the right hand side of the ratio 1. So we do that by dividing both sides by 36.30. So we get 47.50 over 36.30 to 1, and then we want to turn the number on the left into the fraction on the left into a number, So plonk it in your calculator and we get 1.3. So it's 1.321. Cool. Right, it can't get any worse than that. Okay, number 16, 4 marks. In a running club, there are 50 females and 80 males. If a female is chosen at random, the probability she has blue eyes is 0.38. So that means 38% of the females have blue eyes. If a male is chosen at random, the probability he has blue eyes is 0.6. So 60% of the blokes have blue eyes. One person is chosen at random. Show that the probability the person has blue eyes is more than 0.5. Okay, so we need to work out two things. We need to work out how many people are in the running club altogether and how many people have blue eyes. So, for the females, we want to find 38% of 50. So, on a calculator we can just do 0.38 times 50, and that will give you 19. And for the blokes, we just do 0.6 times 80, and that gives us 48. So, total people with blue eyes is 19 and 48, which is 67. Now the total people in the running club is 80 and 50, which is 130. So the fraction of people with blue eyes is 67 over 130. Now that is 0.52 if we go to 2 decimal places. Which is greater than 0.5. Boom. Okay, 17. W is 3 over 5 root x. Circle the expression for w squared. Okay, so 3 to w squared, that's going to give us this whole fraction squared. So we're going to get 3 squared over 5 root x squared. Now that is going to be, well, up on top we got 9, on the bottom we get 5 squared root x squared, so that's 25x. So it's 9 over 25x. There he is. Cool. Okay, question 18, we've got a histogram, so my stuff is down below. So the table shows information about the ages of people at a concert. We want to draw a histogram to represent this data. So, we've got an axis down here. So we have frequency density at the side and age along the bottom. So histograms are these things where you have different width bars next to each other. Now the important thing with a histogram, and the thing that my terrible teacher never pointed out to me, is that each bar is a rectangle. So I was alright making that connection on my own. The height of the rectangle is the frequency density. Now along the bottom you have the interval width. Now the area of each bar is the frequency. So using that we can make this really complicated formula, just area of a rectangle. So what we're going to need to work out here are the frequency densities. So we know from area of a rectangle, frequency density times interval width is equal to frequency. So from that we can get that frequency density is equal to frequency divided by interval width. So in our table, it's going to be slap bang in the way, times. Right, in our table, we are going to work out the frequency densities. They could have given us an extra column, the cheeky monkeys. Right, so we're going to do frequency divided by the width. So 8 divided by 5 is 1.6. Okay, so let's draw these as we go. So this first interval is between 10 and 15. So there's 10, there's 15. Now the frequency density is a bit annoying. One big square represents 0.5, so that means two little squares represent 0.1. So 1.6 is going to be there. Okay, right, how well is this going to go? Probably not. So in the real thing, use a ruler to do this. Cool, so there is our first bar. Now for the second one, we have a frequency of 24 and an interval of 10. So the frequency density is 24 divided by 10, which is 2.4. So there's 15, there's 25, 2.4 is gonna be two little squares below 2.5. So that's gonna be there and there. You don't have to use, obviously, different colours. I just try and make the boring things look a bit more interesting. Right, let's sharpen that up. Cool, so there is our second bar. Let's make this look a bit better. Cool. Right, for the third one. We have an interval of 15 and frequency of 30, so our frequency density is 2. So this is between 25 and 40. So that's 40, there's 25, and we want a frequency density of 2. So that's there. Cool. Okay. That, and then okay, there's our third bar, and then for the final one, 40 to 70, we have a frequency of 30, an interval width, frequency of 39, interval of 30, 39 divided by 30 is 1.3. So, there's 40, there's 70, 1.3, it's going to be 2 little squares above 1.5, so that's there, and there. So, draw the bar in. So, here is our lovely histogram. Cool. Okay, number 19, we have bounds. So the length of a roll of ribbon is 30 meters, correct to the nearest half meter. A piece of length 5.8 meters, correct to the nearest 10 centimeters, is cut from the roll. Work out the maximum possible length of ribbon left on the roll. Okay, so we're thinking best case scenario here. For the maximum length to be left on the roll, we would need the upper bound of the length of the roll minus the lower bound of the length of ribbon cut off. So I'm going to do the error intervals of both because it's good practice. So for the roll, we'll call it R. Before we do that though, we'll get our pen, not our straight line. So R, so it's 30 rounded to the nearest half meter. So the lower bound would be 29.75 and the upper bound would be 30.25. Now let's see the piece cut off, let's call it L. So that's 5.8 centimeters, 5.8 meters, correct to the nearest 10 centimeters. so that's to the nearest 0.1 meter. So the lower bound for that is 5.75. The upper bound is 5.85. So we want the upper bound of R minus the lower bound of L. So 30.25 minus 5.75, and that is going to give us 24.5 meters. Cool. Okay, question 20, probably quite a tricky one. So curve P has equation 2 lots of x minus 1 squared minus 5. Curve Q is a reflection in the y-axis of curve P. Work out the equation of curve Q, giving our answer in the form y is ax squared add bx add c, where a, b and c are integers, so whole numbers. Okay, so transformations of graphs, I've got a video down below. So a reflection of f of x through the y-axis is f of minus x. So that means anywhere that there is an x in curve P, it becomes minus x. So curve Q is y is 2 lots of minus x minus 1 squared minus 5. Now let's expand minus x minus 1 squared. So this means minus x minus 1 times minus x minus 1. So that's going to give us positive x squared. Now we're going to get minus 1 times minus x twice. So that's going to give us positive 2x. And then we get minus 1 times minus 1, which is plus 1. So we've got 2 lots of x squared add 2x add 1 minus 5 at the end. So that is going to give us 2x squared add 4x add 2 minus 5. So then finally that's y is 2x squared add 4x minus 3. Cool. Okay, question 21. So quite a tricky one again, 5 marks. So Priya and Joe both travel the same 16.8 kilometer route. Straight away, write down D is 16.8 kilometers. Priya starts at 9 AM and walks at a constant speed of 6 kilometers per hour. Joe starts at 9:30 a.m. and runs at constant speed. He overtakes Priya at 10:20 a.m. What time does Joe finish the route? Okay, so what we really need to do then is work out Joe's speed. But to do that, we're going to have to process some of Priya's data as well. So let's think about this. When they meet, at 10:20 a.m., Priya has walked for 1 hour and 20 minutes because she started at 9 a.m. So 1 hour and 20 minutes is 1 1/3 of an hour. Now we can work out the distance that she has gone. So remember, speed is distance over time. If you put them in a little triangle like that, cover up the one that we are looking for, and it leaves us with the formula for that one. So cover over D and we get S times T. So the distance at 10:20 a.m. is, so she's walking at a speed of 6 kilometers per hour. So speed times time, 6 times 1 1/3. You can do that on your calculator, or just think about it. 1 times 6 is 6. 1/3 of 6 is 2. So 1 1/3 times 6 is 8 kilometers. Okay, at this point we are now done with Priya. So we now know that Joe runs 8 kilometers in. So he started at 9:30. So they meet at 10:20. So he runs 8 kilometers in 50 minutes. Now, from that we can work out his speed per hour. So we could work out how far he would get in 10 minutes. Divide both sides by 5. So that's 1.6 kilometers in 10 minutes. And then we can work out his speed per hour, which is 60 minutes. So multiply both sides by 6. So we get Joe's speed is 9.6 kilometers per hour. Now, we want to know at what time does Joe finish the route. So for that, we need to know how long the route takes him. So now we want time. So time is distance over speed. So Joe's time is, well, the route is 16.8 kilometers. So 16.8 divided by his speed, 9.6. Now that gives us 2 seconds. That gives us 1 1.75 hours. So that is 1 3/4 of an hour. Now we know Joe started at 9:30, so he finishes at, well, 1 hour after 9:30 is 10:30, 3/4 of an hour after 10:30 is 11:15 a.m. Boom. Okay, number 22, we have iteration. So I've got a video on this down below. This is literally so simple, as long as you know how to use your calculator. So, check out the video. So, an approximate solution to an equation is found using the iterative formula. Xn add 1 is xn cubed minus 2 over 10, with x1 is equal to minus 1. Part A wants us to work out the values of x2 and x3. So, we'll go through this, I'll go through x2, explaining what it means. So, all that we're doing, we are generating terms of a sequence. Xn add 1 means the next term in the sequence. So to get the next term, we cube the previous term, subtract 2, and then divide by 10. So x2 is just minus 1 cubed minus 2 over 10. Now minus 1 cubed is minus 1, minus 2 is minus 3, so we get minus 3/10, or minus minus 0.3. Now to get x3, we put in minus 0.3 wherever there is an xn. But we can use our calculators to do this a lot easier. Okay, so on your calculator, look for the button that says ANS, short for answer. Put in the value for x1, so here, put in minus 1, press equals, you get minus 1. What the answer button does is it remembers the answer from the last time you pressed equals. So what you then want to do is put in the formula xn cubed minus 2 over 10. Now for the xn, put ants. So you're going to get ants cubed minus 2 over 10. So to get x3, we would then need to press equals twice. So if you press it once, you'll get minus 3/10, minus 0.3. Press it again, and you will get minus 0.2027. Okay, and then part B wants us to work out the solution to 5 decimal places. So, from what we've just done above, just keep pressing equals until you get the same display, the same answer every time. And we should get minus 0.20081. Boom. Okay, 23, another 5 marker. So the diagram shows the side view of a stepladder with a horizontal strut of 48 centimeters. the strut is 1/3 of the way up the ladder. The symmetrical cross-section of the ladder shows two similar triangles. So a triangle with the strut as its base is the top triangle that is similar to the overall triangle, which is the whole ladder. We want to work out the vertical height of the ladder, h centimeters. Okay, so we know the slant of the ladder is 141 centimeters. We know it's symmetrical, so we can cut it down the middle, and then we know that this is a right angle, and we know this is a right angle. Now, what we also know is if we cut the strut in half, it's 24 centimeters. Now, because the strut is 1/3 of the way up, the lengths of the small triangle are 2/3 the length of the big triangle, which means that this bottom half of the base is linked to the 24 centimeters above. So let's call this x. Then we know that 24 is 2/3 of x. Now again, that's because the strut is 1/3 of the way up, so the scale factor between the small triangle and the big triangle is 2/3. So if we turn that into an equation, that means 2/3 x is equal to 24. Now we can solve that for x. So 2x is 72, x is 36. So now we know this length here is 36 centimeters. So now we're in a right angle triangle where we know two side lengths and we want a third one. So it's Pythagoras. So by Pythagoras, 141 squared minus 36 squared is equal to h squared. So h squared, that, believe it or not, was an attempt at an arrow. There we go. Therefore, h squared is 2 seconds. Uh, 18,585. So h is the square root of that, which gives us 136.3 centimeters. Cool. Okay, 24, another fun one here. So we're given the formulas for the volume of a sphere and a cone. We are told a sphere has a radius 2x centimeters. A cone has radius 3x centimeters and a perpendicular height h centimetres. The the sphere and the cone have the same volume. At that point, that should be screaming to us, we're going to be forming an equation. If they have the same area, their areas are equal. We want to work out the radius of the cone to the perpendicular height of the cone as a ratio in the form A to B, where A and B are integers. So, at the moment, the radius to the height is 3x to h. But there's all kinds of problems with that. There's an x and a h involved, and we just want the ratio A to B, where A and B are integers. So, this is where we use the info that we're given. So the volume of a sphere is 4/3 pi r cubed. Now the radius of this sphere is 2x. So what we're going to do is find both volumes, set them equal to each other, find what h is in terms of x, and then finish it from there. So, the radius of the sphere is 2x, so the volume of the sphere is, so I like to write it as 4 pi r cubed all over 3, so it's 4 pi times 2x all cubed over 3. Now that gives us 4 pi times 8x cubed over 3, which gives us 32 pi x cubed over 3. Now really that's centimetres cubed, so let's put that there too. Right, then we need to do the same with the cone. So the volume of the cone is given to us up here. So it's 1/3 pi r squared h. So again, I prefer to think of it as pi r squared h over 3. So that's pi times 3x squared h over 3. Now that 3x all squared is 9x squared, so we get 9 pi x squared over h, times h over 3, which is 3 pi x squared h. Okay, so now that we know these two volumes, we know that they are equal. That's centimetres cubed as well. So we know they are the same, so we can now set them equal and find what h is in terms of x. So we now know 3 pi x squared h is equal to 32 pi x cubed over 3. Okay, now then, there's a pi on both sides, so we can divide pi away. So pi goes by and leaves us with 3x squared h is equal to 32x cubed over 3. We have a common factor of x squared on both sides, so we can divide that away, so we get 3h is equal to 32x over 3, and then finally divide 3 by the 3, h is 32x over 9. So remember from the start we had this ratio 3x to h, so we've now got r to h is 3x to 32x over 9. So again, that's come from now that we know that h is 32x over 9. If we then divide both sides by x, we got 3 to 32 over 9, multiplied through by the 9 because we want integers, we get 27 to 32. Boom. Okay, 25 invariant points. So ABCD is a quadrilateral. The quadrilateral is reflected in the line x equals 4, which two vertices are invariant. So invariant points are ones that don't change when you carry out a transformation. So the line x equals 4 is this line. It's everywhere, straight up, from the point x equals 4. So when we reflect the shape, it's going to move over there. So we can see these 2 points, if I drew the line properly, are still exactly where they were. So the invariant points are B and C. Cool. Okay, 26, we got a mix of functions and rearranging algebraic fractions. So I'll put my functions playlist below and my rearranging algebraic fractions video too. So f of x is 2x add 3 over x minus 4. We want to find f inverse. So a lot of teachers would tell you to call f of x y. Why are we getting another letter involved? Don't. Just get lazy with the notation. So just say f is 2x add 3 over x minus 4. Now, what we need to try and do is make x the subject, and then at the end, x and f swap places, and f is now the inverse f. So, multiply through by the bottom, so we get x minus 4 times f is equal to 2x add 3. Expand the brackets, xf minus 4f is equal to 2x add 3. We're trying to make x the subject, so we need to get the x terms on the same side. So I'm going to subtract 2x, so we get x f minus 2x minus 4 is equal to, minus 4f is equal to 3. Now, any terms that don't involve x, move those to the other side. So we're going to add 4f. So xf minus 2x is equal to 4f add 3. Now on the left, the magic step here to turn these two x terms into one x term is to factorise. So we get x times f minus 2 is equal to 4f add 3, divide 3 by the bracket, x is equal to 4f add 3 over f minus 2. And now the final step, the x now becomes f inverse and the f's become x. So we get f inverse is 4x add 3 over x minus 2. Boom. 27 is the final big question, and it's simultaneous equations, just a bit weird. So these papers, I would say, are very A-level-y. This is a good example of that. So, the line y is 3x add p, and the circle x squared and y squared is 53, intersect at points A and B. P is a positive integer, so a positive whole number. We want to show that the x-coordinates of points A and B satisfy the equation 10x squared add 6px add b squared minus 53 is equal to 0. Okay, so at points where lines and circles meet, the equations are simultaneous. So we are going to use substitution because we know that y is 3x add p, into x squared add y squared is equal to 53. Now we can do this again because at points of intersection, lines, curves, circles, whatever, are equal. So if y is equal to 3x add p, we convert that expression for y into x squared add y squared is 53. So we get x squared add 3x add p squared, so y squared has become 3x add p squared is equal to 53. So if we expand those brackets, we got the x squared. Now make sure that you can get 9x squared add 6x p add p squared is 53. Now this is a quadratic, so as with any quadratic that you're going to solve, you want to get everything on the same side. So we got 10x squared add 6x p add p squared, and then we're going to subtract the 53 and then we get is equal to 0, as we wanted. Okay, so then we're told for part B, and 5 marks, the coordinates of A are 2, 7. Work out the coordinates of B. Okay, so what this is telling us is that we know that point A is a point on the line y equals 3x add p. So, we know that y is 3x add p, and we also now know that when x is 2, y is 7. So this is going to allow us to find the value of p. So when x is 2, y is 7, that tells us then that 7 is equal to 3 times 2, so 6. Add p. Therefore, we know that p is equal to 1. So now we're going to sub p equals 1 into what we've just done, 10x squared add 6x p add p squared minus 53 is equal to 0. Now that's going to leave us with a quadratic purely in terms of x. We can then solve that for x and then do what we need to do. So that's going to give us 10x squared add 6x, and then we got add 1 minus 53, so that's minus 52 is equal to 0. Now thankfully in that there is a common factor of 2 that we can divide away, so we're going to get 5x squared add 3x minus 26 is equal to 0. Now, to factorise this, we know we're going to need a 5x to get 5x squared. So, that's taking care of the 5x squared. Now, we know that our two numbers need to multiply together to minus 26. So that tells us one number is negative and one is positive. Now, we actually know one of the x values, which is a solution. We know that at point A, x is equal to 2. So to get a solution of positive 2, one of our brackets needs to be x minus 2. So that's minus 2 to get the negative 26. The other one has to be plus 13. So we can of course check that that works. Minus 2 times 5x is minus 10x. 13 times x is 13x. Minus 10x add 13x gives us that plus 3x that we need in the middle. So we know from the right hand bracket x is 2, we don't care about that. The one that we care about is 5x add 13. So when you are solving quadratics from factorised form, you set whatever is inside a bracket equal to 0. So we get 5x add 13 is equal to 0. So 5x is minus 13 divided by 5 gives us x is minus 2.6. So we now know the x coordinate of point B is minus 2.6. Now to get the y coordinate, remember we know that y is 3x, add 1, so y is 3 times minus 2.6, add 1. 3 times minus 2.6 is a number 6 minus 7.8, so add 1 gives us y is minus 6.8. So those are our coordinates. Okay, the final question. So again, quite A-levelly, we're thinking about the gradient of a curve. When has anyone at GCSE been taught about the gradient of a curve? Probably not much. So, we got a quadratic curve. The turning point is 3 minus 2. So this point here, we're asked to circle the correct statement about the gradient of the curve for x is less than 3. So x less than 3 is everywhere to the left of the turning point. At a turning point, gradient is equal to 0. Now, with straight lines, that is negative gradient. That is positive gradient. So we can see that the curve is going down from left to right. So the gradient is negative for x less than 3. So there it is. Okay guys, on that, the paper is done. Really hope you found it useful. Quite a tricky paper, I'd say. Don't forget, give us a thumbs up, get subscribed. Good luck in your exams, take it easy, take care.